Okay, so an important case of variation or of what we're going to call microevolution. And this is 7.8 of the AP curriculum, continuing evolution. And this has got to do with antibiotic resistance. That's a case of microevolution. We're not getting a new species, but we're getting changes within a population over time. So not a new species, but changes in the variations of that species is microevolution. So introduction of antibiotics for the treatment of bacterial infections becomes the chemical selection pressure. Antibiotics, it's a selection pressure. Bacteria like methicillin-resistant Staphylococcus aureus, or MRSA, have evolved antibiotic resistance via natural selection. There are many reasons for this. Variation in all species, we know that. There are mutations in the DNA as a form of that variation. These enable the bacteria to produce potent enzymes that inactivate antibiotics. Bacteria can transfer the genetic information for antibiotic resistance by asexual reproduction. Okay, so as you're going to learn in Bio30, there's a way of doing this, exchange of what's called a plasmid, a little bit of their DNA, a circular chromosome, extra chromosomal DNA that gets transferred over. Other reasons involve applying a selective pressure on a population. For example, taking antibiotics when not necessary, not completing the dosage. The doctor says, hey, take your antibiotics until all of them are empty, and you forget about it because you feel better, you stop taking antibiotics. And using antibiotics for things that aren't going to stop infections, like viruses. No, we don't need antibiotics for viruses because viruses aren't bacteria. The antibiotic kills most of the bacteria, but a few individuals carrying the mutation survive and they pass them on. And then the patient therefore develops antibiotic resistance. Okay, so to 7.8, continuing evolution, antibiotic resistance. Let's take a look at it. A bunch of bacteria, including a resistant variety. Remember, that's one with the variation. This is species diversity, just happens to be in the population. It's a mutation that's allowed it to be resistant to antibiotics. Now we're going to take our first dosage of antibiotics, get bathed in antibiotics. Most of the normal antibiotics die. A few survive, but oh, look at this. Okay, what happens next? Number 3, the bacteria multiply and become more active. Eventually, the entire infection evolves into a resistant bacterial strain. So what would happen if this is now your MRSA? What would happen if you gave this antibiotics? Well, they'd survive. That's why prescription antibiotics is so deadly. Okay, if you overprescribe them, you can develop antibiotic resistance. So this is evolution, a microevolution in action. Okay, think about it. Variety. We've got variety. Then we introduce a selection pressure. Okay, and those that are fittest, survival of the fittest, those that are fittest, in other words, they've got the variation, survive. Now, be able to apply that to the giraffe story. What would Lamarck have said about this? The environment changed and these somehow willed themselves to survive. They adapted to the environment. No, they just happened to be born with the variation. Okay? They pass that on. Okay, so names you need to know. Linnaeus, Cuvier, Linnaeus, Cuvier, we looked at Malthus, Lamarck, Darwin. We also mentioned Wallace, okay? Now there's a few others in your textbook. Just read through them, please. This is diagrams in your textbook, and that's good. Yeah, so read through the other people in your textbook as well. Okay, so let's go back to this idea of biotic, abiotic factors today. Ecosystem is the interaction of living and non-living things in the environment. Now remember, this is part of that Bio 20 unit, populations and ecosystems, change in populations and ecosystems. So here is our population. Species that are capable of inbreeding produce a population. When we have several populations together, we have a community. Now when they start interacting with their abiotic factors, remember these are all biotic. When the biotic and the abiotic interact, we have an ecosystem. And several ecosystems form the biosphere. Biotic abiotic factors significantly differ significantly in different ecosystems. Abiotic factors create a selection pressures that select for different types of organisms and hence affect the biotic. The underlying abiotic factors of an ecosystem therefore must be studied in order to determine the possible effect that they may have on the biotic. An organism's ecosystem provides it with nutrients, water, shelter, opportunities to mate. Other living things compete with it for these resources. This competition results in some organisms being able to survive and reproduce while others aren't able to, okay? As a result, individuals in the successful species will have a range of favorable characteristics. Okay, I want to look at some of those more detail, those adaptations. These are characteristics in an organism that's inherited that enhance your survival. They result from natural selection, result from a change or variation that arises at random. This random difference may happen to benefit the organism. Difference may be passed on, or the chance of survival may be increased with adaptations. Let's look at some. They come in structural or physical, physiological, or behavioral adaptations. Structural adaptations in plants, we're going to draw on some of my Australian ones, Melaleuca species, okay, are covered with little hairs to reduce water loss, okay? So those that have the hairs are better able to survive because they don't dry out as easily. In animals, this is called the thorny devil. And this is a wombat. Notice its pouch. It's got a rear-facing pouch. Why are these physical adaptations? Well, this wouldn't be for protection, okay? I would not want to eat it, okay? So that would be adaptations. The rear pouch is because it's a burrowing animal, and by burrowing forward and grazing forward, it's not going to get dirt shoved up in its pouch. It's a marsupial pouch now. Those would be physical or structural adaptations. Okay, let's look at these. The beak is an adaptation. Camouflage is an adaptation. The feathers for mating, adaptation. The spikes, the ears or the eyes on the side of the head. And these eyes on the wing of this moth would be adaptation, because if I'm a bird, I'm going to see this and I'm going to either bite the head. So many of these moths lose parts of their wing right there. Or I'm going to say that that's a big animal. I want to leave it alone. Physiological involve variations in the metabolism or physiology of organisms at a cellular level. Okay, in this plant here, again, Australia, they have salt plants. Okay, so these are mangroves. And the mangroves grow in oceans. And they need to get rid of their salt. So they've got salt glands to do that. That's physiological. These penguins, emperor penguins, can stand on ice for a very long period of time because of what's called countercurrent heat exchange. Your feet never get that cold because cold blood is being replaced by warm blood, okay? And then the warm blood warms the cold blood before it goes back to the heart. Obviously, venom would be a physiological adaptation. Okay, mucus is a physiological adaptation. And we could argue the ears themselves are a structural adaptation, but they're large to lose heat. So all the blood vessels in there, you could argue would be a physiological adaptation. They have to lose heat, even though the ears are structural. Okay, but definitely the mucus, the venom, these are clear examples of physiological. But here's an example how they kind of blend, interact. Physiological adaptations. Behavioral. If I touch this plant, okay, this mimosa plant, it shrinks. This brown snake in Australia, one of the most deadly, I saw a number of them when I was there hiking, okay? It comes out to sun itself in the morning. It needs to do that to heat up because otherwise it won't be able to move. It's an ectotherm, okay? It's not a homeotherm like a human, where our body temperature is constant. So that would be a behavioral adaptation sunning itself. Okay, grooming is a behavioral adaptation. Migration is a behavioral adaptation. Hibernation, behavioral, and a beaver slapping its tail are also examples of behavioral adaptations, all increasing the organism's chance of survival. Okay, we'll leave it at that.